The cosmos holds secrets that defy all logic. We are about to explore 25 of the most bizarre cosmic events ever recorded, phenomena that have left even the most experienced astronomers completely stunned. By the end of this journey, you will discover the universe is far stranger than any science fiction. We will encounter a star that dims in inexplicable ways and a signal from the void that has never been repeated. What do you think is the most profound mystery waiting for us in the dark? On August 15, 1977, a radio telescope in Delaware, Ohio, picked up a signal so powerful and so strange that it defied all conventional explanation. It was not a random burst of static. This was a narrowband radio signal, the exact type scientists predicted an advanced civilization might use to broadcast its existence. The signal lasted for 72 seconds, rising and then falling in intensity, a perfect arc as if it had passed directly through the telescope's field of view. It came from the direction of the constellation Sagittarius. When volunteer astronomer Jerry Amon reviewed the computer printout days later, he was so stunned by the string of alphanumeric characters, 6EQUJ5, that he circled the sequence and wrote a single, powerful word in the margin. Wow, that single word gave the signal its name and the mystery its life. The code itself, 6EQUJ5, was a measure of the signal's intensity. Each character represented a number with letters used for values above 9. The U stood for an intensity level of 30, a signal 30 times stronger than the empty space around it. Nothing natural known to science, no pulsar or quasar, produces such a focused, powerful burst in that specific frequency. For one brief moment, it seemed we might not be alone. Theories have flown for decades in an attempt to explain it. Some suggested it was a transmission from a passing human satellite or a reflection from space debris. Others proposed it was caused by a comet, though subsequent investigations found no comets in that region of the sky at that time. The most captivating and unsettling theory is that it was a one-time message, a cosmic hello from a distant intelligence that we simply were not quick enough to answer. Despite numerous and exhaustive searches, the WOW signal has never been heard again. It remains a silent siren, a ghost in the cosmic machine that continues to haunt our search for meaning in the vast, quiet dark. While the WOW signal was a fleeting cry from the void, another mystery was hiding in plain sight within a mountain of public data. Citizen scientists, ordinary people sifting through the flood of information from the Kepler Space Telescope, noticed something impossible about a star 1,400 light-years away. It was designated KIC 8462852, but the world would come to know it as Tabby Star. Unlike other stars monitored for the telltale, periodic dimming of an orbiting planet, this star's light did something bizarre. It would drop in brightness by staggering amounts, up to 22%, and it did so in a chaotic, unpredictable pattern. A planet, even a giant one, would only block about 1% of a star's light. This was something else entirely, something colossal and irregular passing in front of the star. The scientific community scrambled for an answer. The initial and most natural explanation was a massive swarm of comets, a family of icy bodies breaking up and creating a vast, uneven cloud of dust and debris. Yet the scale required was almost as unbelievable as the dimming itself. This led to a more speculative yet irresistible theory. What if we were seeing the shadows of a megastructure, an alien construction project on a scale we can barely comprehend, like a Dyson sphere designed to harvest a star's energy? The idea captured the public imagination, but scientists remained rightly skeptical, searching for more conventional causes. They have monitored Tabby Star for years, watching as it continues to dim in sudden, dramatic ways that no model of stellar behavior fully explains. It is a cosmic puzzle box, a star that winks at us with a secret we have yet to decode. Far from the chaotic flickering of Tabby Star, a structure of impossible geometry hangs in the void. Near the constellation Monoceros, 2,300 light-years away, lies a cosmic art piece known as the Red Rectangle Nebula. It is not truly rectangular, but its appearance is so sharp and angular it defies the soft, billowing clouds we associate with most nebulas. At its heart is a pair of aging stars, a binary system locked in a tight dance. As these stars near the end of their lives, they have been casting off their outer layers for millennia. But this is not a gentle, symmetrical shedding. The key to the nebula's bizarre shape lies in the wobble or precession of the jets screaming away from the stellar poles. Imagine a spinning top as it begins to slow down, its axis tracing a slow, wide circle. Now picture that motion applied to two powerful beams of gas ejected from the stars. This precession carves out a vast, double-coned structure of dust, and from our vantage point on Earth, that cone appears as a perfect, haunting X shape. Surrounding this central cross are a series of concentric, reddish steps, like the rungs of a cosmic ladder, giving the nebula its iconic rectangular silhouette. The deep red color itself is another piece of the puzzle, coming from a class of complex organic molecules known as polycyclic aromatic hydrocarbons. These are essentially large, carbon-based compounds, the same kind of sooty material found in car exhaust or a charred barbecue grill. Here, in the cold emptiness of space, their presence is a tantalizing clue. They are the building blocks of life, forged in the final, dying breaths of a star system. The red rectangle is not just a beautiful anomaly, it is a cosmic factory, sketching the blueprints for future worlds in glowing gas and geometric dust. A violent cosmic feast can leave the most unexpected of aftereffects. In 2016, astronomers witnessed something that seemed to rewrite the rules of how black holes behave. A supermassive black hole at the heart of a distant galaxy cluster, having torn apart and consumed a star years earlier, did something astonishing. It let out a powerful belch, a massive outburst of high-energy radiation. But this was no immediate reaction. The event that triggered it, the star's destruction, had occurred years before. This delayed blast was a cosmic burp that arrived startlingly late to the dinner party. The discovery fundamentally challenged everything scientists thought they knew about how black holes feed. The prevailing model was relatively straightforward. When a star wanders too close to a black hole's immense gravity, it is stretched and pulled apart in a tidal disruption event. The stellar material is then whipped into a hot, swirling disk of gas and debris called an accretion disk, which spirals into the black hole, releasing a tremendous flash of light and radiation in the process. This was thought to be a rapid and direct sequence of events. The observation of the delayed burp, however, suggested something far more complex. It implied that the accretion disk is not a simple, one-way chute into oblivion. Instead, it can act like a cosmic stomach, capable of storing and trapping enormous amounts of this stellar material for years before deciding to violently expel some of it back out into space. This forces us to reconsider the very mechanics of these gravitational monsters. What internal processes, what magnetic fields or pressure buildups could cause such a long delay between the meal and the belch? It reveals that black holes are not merely simple drains in the fabric of space, but dynamic, messy eaters whose digestion takes place on a timescale we are only just beginning to perceive. Yet even the most violent black hole is a predictable beast compared to the fleeting phantoms haunting our own solar system. Far beyond the familiar orbits of Mars and Jupiter, in the deep, cold reaches where the sun is just a brilliant pinpoint, the ice giant Neptune holds a secret. Astronomers using the Hubble Space Telescope have witnessed the birth and death of vast, dark storms swirling in its hydrogen and helium atmosphere. These are not permanent fixtures like Jupiter's famous Great Red Spot. They are cosmic ghosts appearing for a few years and then vanishing without a trace. One of the most dramatic, a massive dark vortex wider than the entire Atlantic Ocean, was a perfect example of this profound mystery. This colossal storm system, a high-pressure anticyclone, spun counterclockwise, dragging frozen, frigid material up from the planet's deeper layers. But the vortex itself was not what astronomers saw first. They were drawn to its brilliant white companion clouds. These are not made of water vapor, but of methane ice crystals. As winds are forced to rise over the immense vortex, the air cools, causing the methane gas in Neptune's atmosphere to freeze into bright, white clouds that float high above the dark storm like luminous, fluffy caps. The dark vortex itself is a hole in the upper cloud deck, a window into the planet's stormy depths. The greatest puzzle is not their existence, but their fleeting nature. What forces on Neptune are powerful enough to spontaneously create a storm the size of a planet, only to have it disintegrate just a few years later? We watch these giants form, rage, and die, all while we struggle to understand the hidden engine driving their brief and spectacular lives. The mystery of Tabby Star only deepened as astronomers looked further back in time. They unearthed a treasure trove of old photographic plates, a century's worth of data showing this star had been slowly, steadily fading for decades. This was not just about the bizarre, sharp dips that blocked a fifth of its light. It was also about a long, slow dimming that no normal star of its type should exhibit. Combined with the chaotic, aperiodic flickering, it painted a picture of a star under siege by something vast and complex. The short-term dips were not periodic like a planet's orbit. They were erratic, with different shapes and durations, as if a collection of objects of all different sizes were tumbling in front of the star in a chaotic swarm. The alien megastructure theory, while captivating, was always a hypothesis of last resort. Science demanded a natural explanation, and the most compelling one to emerge involves dust, but dust of a very peculiar kind. The key evidence came from the star's own light. When it dimmed more in blue light than in red light. This is a classic fingerprint of starlight filtering through a cloud of fine particles. Much like our sun appears redder at sunset as its light passes through more of Earth's dusty atmosphere. The leading theory now suggests a vast, uneven ring of circumstellar dust, debris from the collision of planets or moons orbiting the star. This dust cloud would be clumpy and dynamic, its densest patches causing the sharp, deep dips, while the overall cloud contributes to the long-term fading. But even this explanation has its own puzzles. The dust particles seem to be exceptionally fine, smaller than particles of smoke, which is unusual for such an environment. So while the alien megastructure idea has retreated from the spotlight, it has not been completely ruled out. The fundamental question remains: what natural process could create and sustain such an immense, intricate, and ever-changing shroud of dust around a single star? The debate continues, a perfect example of how the most thrilling cosmic mysteries are not always solved, but often just evolve into new and more refined questions. While we grapple with storms on Neptune and dust around distant stars, a far more violent process unfolds at the very heart of our galaxy. Near the crowded galactic center, a cosmic object with a terrifying name wages a constant war against existence itself. Astronomers call it the Great Annihilator. Its official designation is a string of numbers and letters, 1E1740.7-2942, but its nickname tells you everything you need to know. This is a unique binary system, a pair of cosmic dancers where one partner is either a black hole or a neutron star, and the other is a normal companion star. The smaller, denser object is a gravitational bully, relentlessly pulling gas away from its stellar neighbor. As this stolen material spirals inward at nearly the speed of light, it heats up to millions of degrees, creating a swirling, hellish disk of plasma. From the poles of this accretion disk, powerful jets of particles are launched out into space, but the jets from the Great Annihilator are not normal. They are beams of pure antimatter. Specifically, they are streams of positrons, which are the antimatter counterparts to electrons. When a positron meets a normal electron, the two particles do not simply bump into each other. They annihilate each other in a flash of pure energy, vanishing and converting their entire mass into two intense gamma-ray photons. This is the process that gives the Great Annihilator its name. We detect it by the constant, powerful glow of these gamma rays, the signature of annihilation happening on a cosmic scale. This makes the system a priceless natural laboratory. On Earth, creating and containing even tiny amounts of antimatter requires immense particle accelerators like the Large Hadron Collider, and it is an incredibly difficult and energy-intensive process. Yet here, near the center of the Milky Way, the Great Annihilator does it effortlessly, manufacturing and firing antimatter beams across light years. It provides a front-row seat to one of the most fundamental and violent processes in the universe, a place where matter and antimatter meet in a perpetual dance of mutual destruction, illuminating the darkness with the light of their own obliteration. The violence of the Great Annihilator is a slow, steady burn, but in 2018, the universe delivered an explosion of such ferocious speed it seemed to break all the rules. In a galaxy 200 million light-years away, a pinpoint of light erupted into existence, reaching peak brightness in a matter of days, not weeks. This event was so unusual it was promptly given a name that matched its strange nature, a T2018 cow. The name came from the automated system used to assign designations, a simple sequence of letters, but for astronomers, the cow became an instant and profound mystery. It was absurdly luminous, outshining a typical supernova by at least 10 times, and it evolved at a pace that was almost unbelievable. It flared up and then faded away in just a few weeks, a process that should take months or even years for a dying star. The spectrum of its light was the most bizarre part, a chaotic mess lacking the familiar fingerprints of common elements like hydrogen or helium that are seen in standard supernova explosions. This was not a clean, well-understood death. It was something entirely new. The scientific community was immediately divided, with theories flying in an attempt to explain the cow's bizarre behavior. One leading idea proposed that this was a special type of supernova, the death of a massive star that left behind a powerful central engine. Think of a rapidly spinning, highly magnetized neutron star known as a magnetar. This newborn, hyper-dense object would be pumping enormous amounts of energy into the expanding debris of the exploded star, like a cosmic motor revving the afterglow to incredible intensities and causing its rapid rise and fall. The other major theory was even more violent. Perhaps this was not a supernova at all, but a tidal disruption event, a star being completely shredded by an intermediate mass black hole. In this scenario, the intense luminosity would come from the accretion disk formed from the stellar debris, a sudden, brilliant feast in the cosmic dark. The cow did not neatly fit either category, forcing astronomers to consider that they were witnessing a brand new class of astronomical transient. It was a cosmic birth cry, a signal that our catalogue of stellar deaths was tragically incomplete, and that the universe holds in reserve explosions of a type and speed we are only just beginning to perceive. While the cow was a violent flash in the dark, another cosmic object provides a rhythmic pulse of almost perfect precision. Deep within the constellation Virgo, a stellar corpse spins at an unfathomable speed, acting as a celestial lighthouse. This is PSRB 1257+12, a pulsar discovered in the early 1990s that immediately redefined what we thought was possible. A pulsar is a type of neutron star, the incredibly dense, collapsed core of what was once a massive star. This one rotates hundreds of times every single second, and from its magnetic poles, it fires out twin beams of intense radiation. As the star spins, these beams sweep through space like the beacon of a cosmic lighthouse. From our vantage point on Earth, each time a beam flashes across our line of sight, we detect a pulse of radio waves, The regularity of these pulses is staggering, more precise than the most accurate atomic clocks we can build. But the true astonishment came when astronomers noticed a tiny, rhythmic wobble in its otherwise perfect timing. Something was gently tugging on this super-dense stellar remnant, causing it to wobble in space. The only explanation was the presence of planets. This discovery was monumental. PSRB 1257 plus 12 became the very first star outside our own solar system confirmed to have a planetary system. Yet this was no placid, sun-like star-nurturing worlds. This was the aftermath of a supernova, one of the most violent events in the universe. The existence of these planets posed a profound and immediate question. How could any world possibly survive the stellar explosion that created the pulsar itself? One theory suggests these are second-generation planets. The cataclysm that forged the neutron star would have utterly obliterated any original planets that orbited the progenitor star. The planets we detect now must have formed from the fallen debris, a new family of worlds coalescing from the ashes of the old. These pulsar planets are bathed not in warm, nurturing sunlight, but in a constant, deadly sleet of high-energy radiation from the pulsar's beams. They are hellish landscapes, likely barren and irradiated, proving that planet formation is a tenacious process, capable of occurring even in the most hostile graveyards of dead stars. This cosmic lighthouse does not just mark a location in space, it signals a fundamental truth about our universe. Life, in its most basic planetary form, can find a way to begin again, even after total annihilation. If the pulsar planets were a testament to cosmic survival, then the world known as PSR J1719-1438b is the ultimate prize. Discovered in 2011, this planet is the distilled essence of a star's corpse, a world that is quite literally a diamond of unimaginable scale. It orbits a millisecond pulsar, a neutron star spinning so rapidly its surface moves at a significant fraction of the speed of light. But the planet itself is the true marvel. It is not a gas giant or a rocky world like Earth. Scientists believe it is the crystalline carbon core of a white dwarf star that ventured too close to its pulsar companion. The story of its creation is one of cosmic cannibalism. The pulsar's intense gravity relentlessly pulled material away from the doomed white dwarf, stripping away its outer layers of hydrogen and helium over billions of years. This left behind only the star's incredibly dense inner core, a sphere of carbon that was once about the size of Earth but has been compressed by its own immense gravity to a size smaller than Jupiter. Under the staggering pressures within this remnant, the carbon atoms were forced into a rigid, crystalline structure. In essence, the entire planet is one gigantic diamond, 5 times the size of our own world. Its density is so extreme that a single teaspoon of its material would weigh many tons on Earth. While the idea of a diamond planet captures the imagination with its sheer, incalculable value, the reality of this world is far more alien than any treasure chest. It is a dead star's heart, crystallized forever in the unyielding grip of gravity, a glittering monument to the universe's capacity for both destruction and breathtaking creation. Deep within the constellation Cassiopeia lies the ghost of a star that died 3 centuries ago. This is Cassiopeia A, the scattered, expanding debris from a supernova explosion, a sight of chaotic beauty and relentless energy. But sometimes the dead leave behind more than just a remnant. They can project their image across space and time, creating phantoms that haunt the cosmos long after their light has faded. This is the story of a green ghost, a cosmic apparition discovered not by a seasoned astronomer, but by a school teacher named Hanny van Arkel. While sifting through images from the Galaxy Zoo project, she noticed something impossible next to a distant spiral galaxy. It was a vast, glowing, greenish-blue cloud of gas, a structure with no stars in it at all. It was named Hanny's voorwerp, which is Dutch for Hanny's object. This vorwerp was a cosmic mystery. What was this immense, isolated cloud, and what powerful source was making it glow with such an unearthly light? The answer was a phenomenon known as a light echo. The supermassive black hole at the center of the nearby galaxy, IC 249, had once been a brilliant quasar, a beacon of intense radiation. That quasar activity has since shut down, falling silent. But the light from its brilliant past had traveled outwards, and when it struck the vorwerp, a massive cloud of gas floating in intergalactic space, it ionized the gas. This means the energetic radiation stripped electrons from the atoms in the cloud, causing it to glow with a faint, eerie light, much like a cosmic neon sign. The quasar itself is now dark, a dead engine, but its ghost, the light it emitted thousands of years ago, is still traveling through the universe, and we see it now, illuminating a phantom cloud that should not be visible. This is not unique to Hani's vorwerp. Similar light echoes can be created by supernova. The initial flash from an exploding star races outwards at the speed of light. If that light later strikes a distant, pre-existing cloud of interstellar dust, the cloud can light up, reflecting the image of the explosion long after the star itself has vanished. We are not seeing the event in real time. We are seeing its reflection, its memory etched onto a cosmic canvas. These celestial ghosts remind us that the universe is a hall of mirrors, where the light of a long-dead star or a vanished quasar can still speak to us, telling stories of past cataclysms from beyond the grave. Some stars are born to run, moving with a velocity so immense they can break free from our galaxy entirely. These are the hypervelocity stars, cosmic fugitives fleeing the Milky Way's gravitational grip at speeds exceeding 1 million miles per hour. One of the most famous, known as US 708, is a stellar rebel on a one-way trip into the intergalactic void. It is a white dwarf, the burned-out core of a sun-like star, yet it streaks through space faster than any other star of its kind we have ever found. The question is, what cosmic slingshot could possibly impart such an incredible speed? The prime suspect resides at the very heart of our galaxy, the supermassive black hole known as Sagittarius, a star. The leading theory is a gravitational three-body interaction, a celestial game of billiards played with terrifying stakes. Imagine a binary star system, two stars orbiting each other, drifting too close to the black hole's immense gravity well. The black hole's pull could violently tear the binary pair apart, capturing one star into a tight orbit while flinging the other away at a phenomenal velocity, like a stone from a sling. This process, known as the Hill's mechanism, is the most plausible engine for these stellar projectiles. Tracking their precise origins is a monumental challenge as their paths wind back through millions of years of travel. By tracing their trajectories backward, astronomers can use these stars as probes, their speeds and compositions offering clues about the chaotic environment near our galaxy's central black hole. They are living tracers, their flight paths mapping the invisible forces that shape the cosmos, proving that even the darkest of gravitational monsters can create the most brilliant of runaway stars. While hypervelocity stars race away from our galaxy, a far more subtle and invisible storm is passing through us right now. A dark matter hurricane is currently sweeping through our solar system, an event predicted by astronomers studying the shredded remains of an ancient dwarf galaxy. Billions of years ago, our own Milky Way cannibalized this smaller neighbor, known as Sagittarius, tearing it apart with its immense gravity. What remains of that galactic feast is not just a trail of stars, but a vast, fast-moving stream of dark matter, and our solar system is now sailing directly into it. This is not a storm of wind and rain, but a silent, invisible gale of the universe's most mysterious substance. We cannot see dark matter, we cannot touch it, and we have never directly detected a single particle of it. Yet we know it must exist because its gravitational pull is the only thing that explains how galaxies spin without flying apart, and how the largest structures in the cosmos hold their shape. It makes up roughly 85% of all the matter in the universe, a hidden skeleton upon which the visible world is built. This hurricane offers an unprecedented chance to finally feel its presence. The stream is moving at a staggering speed, over 500 kilometers per second, which means the particles are striking our planet with much more energy than the typical, slower-moving dark matter that pervades our galactic neighborhood. This higher energy signature is crucial. Detectors buried deep underground, shielded from cosmic rays and other interference, are constantly listening for the faintest whisper of a dark matter particle colliding with a normal atom. The passing hurricane dramatically increases the odds of such a collision. It is like trying to hear a single, quiet pin drop in a noisy room, and then suddenly a louder, faster pin is thrown into the mix. Scientists are now tuning their exquisitely sensitive instruments, hoping to catch a unique signal from this cosmic gale. Discovering dark matter would be one of the greatest scientific breakthroughs in history, finally revealing the true nature of most of the mass in the cosmos. This invisible hurricane is our best chance yet to listen to the wind of a hidden universe, a wind that has been blowing since the dawn of time. That same invisible dark matter, the hidden architecture of the cosmos, should have guided the formation of galaxies into a vast, web-like structure, with great clusters connected by filaments and separated by immense, empty bubbles. But one of these bubbles is so profoundly empty it defies belief. In the direction of the constellation Boötes, there exists a spherical region of space so vast it could contain thousands of galaxies like our Milky Way, yet it holds almost none. This is the Boötes Void, a cosmic desert nearly 330 million light-years across. If our solar system were at its center, we would not have known other galaxies existed until the 1960s. The emptiness is not absolute. A handful of isolated galaxies dot the void like lone islands in an ocean of nothingness, but their presence only deepens the mystery. How could the universe, which seems to clump matter together so effectively, create a whole of this magnitude? The standard model of cosmology has a difficult time explaining it. The tiny fluctuations in the early universe, imprinted during the period of rapid inflation, should not have produced a void this large and this empty. It is an outlier of staggering proportions. One compelling theory suggests it is not a single void, but the result of several smaller voids merging together over billions of years, like soap bubbles coalescing into one gigantic cavity. Another, more speculative idea involves the physics of the universe's first moments. Perhaps a defect in the fabric of space-time itself during cosmic inflation created a seed for this ultimate emptiness. The Boötes Void stands as a silent challenge to our understanding, a reminder that the grand cosmic web may have holes in its weave far larger than we ever thought possible. What other immense structures or absences of structure lie waiting in the dark, forcing us to redraw the map of everything we think we know? Even a star's death is not always final. Deep within the constellation Ursa Minor, a supernova designated 2012 Z demonstrated a baffling new way for a star to die. It was a type IX supernova, a category so peculiar it behaves more like a cosmic dud. This is the story of the zombie star, a stellar remnant that somehow survives its own violent suicide. A traditional type Ia supernova is a definitive end, a runaway thermonuclear explosion that utterly annihilates a white dwarf star, leaving nothing behind but an expanding cloud of stellar debris. But the type IX event is different. It is a weaker, fizzling blast. Astronomers believe it begins the same way, with a white dwarf siphoning material from a companion star until it reaches a critical mass. Yet in this scenario, the nuclear fire does not consume the entire star at once. Instead, the explosion rips through the white dwarf asymmetrically, violently ejecting a portion of its mass into space but failing to achieve total obliteration. What remains is a scarred and battered stellar corpse, a zombie star that continues its existence after its supposed death. This survivor is still a white dwarf, but it is a ghost of its former self, having been blasted and stripped of layers, sent hurtling through space at an incredible speed by the force of the partial explosion. The discovery of these events fundamentally challenges the textbook definition of a supernova. We have always classified these explosions as the final, complete destruction of a star. The zombie star proves that a star can endure its own funeral pyre, a half-dead, half-alive testament to the universe's refusal to follow our simplest rules. What other cosmic events do we assume are absolute, when in reality, they might exist in a strange and partial state between life and death? These stellar zombies are not the only phantoms challenging our cosmic maps. In 2019, astronomers conducting a vast radio sky survey stumbled upon something that should not be there. Structures so strange they were named, with scientific directness, odd radio circles, or ORCs. These are not faint, fuzzy blobs. They are immense, perfect rings of radio emission, so gigantic they could easily swallow entire galaxies whole. The most baffling quality is their invisibility. They do not appear at all in optical light, nor in infrared, nor in X-rays. They are ghosts in the radio spectrum, vast, empty halos of energy that reveal nothing of their core. You cannot point an optical telescope at their coordinates and see anything but the normal, distant field of galaxies behind them. It is as if someone has drawn glowing circles on the sky with invisible ink, visible only through the most specialized of radio eyes. Their discovery sent theorists scrambling. What natural phenomenon could possibly create such enormous, symmetrical, and isolated structures? One leading idea points to a galactic-scale shockwave. Imagine the powerful winds generated by a burst of star formation within a galaxy, or perhaps by the jets from a supermassive black hole. These winds could blow outwards for millions of years, eventually colliding with the thin gas that exists between galaxies. That collision could create a spherical shockwave, a ripple in the intergalactic medium that accelerates electrons, causing the entire sphere to glow in radio waves. From our distant perspective, we would see this immense sphere as a near-perfect circle. Another, more exotic theory suggests these could be the throats of wormholes, the hypothetical tunnels in space-time. According to some models, the mouth of a wormhole could theoretically produce a spherical radio emission, though this remains a highly speculative and thrilling possibility. A third proposal is that an ORC is the remnant of a gargantuan explosion, unlike any supernova we know. Perhaps it is the echo of a merger between two supermassive black holes, an event so cataclysmic it sent a spherical blast wave racing through intergalactic space for eons. Each of these explanations pushes the limits of known physics. The true nature of these cosmic rings remains one of the newest and most compelling puzzles in astronomy, a reminder that even our most advanced sky surveys are still capable of finding things that for now have no name. A cosmic monster is on the loose, fleeing the scene of a catastrophic crime. In 2017, astronomers spotted a supermassive black hole, a behemoth with a mass millions of times that of our Sun, doing something that should be impossible. It was not resting at the heart of its galaxy. Instead, it was hurtling through intergalactic space at incredible speed, and it was leaving a brilliant contrail of newborn stars in its wake. This was a runaway black hole, a gravitational titan evicted from its home. The scene was one of violent beauty. A long, almost straight line of young, intensely blue stars stretched across the cosmos, a stellar umbilical cord connecting the rogue black hole to the galaxy it left behind. These stars were a direct result of the black hole's frantic journey. As it plowed through the dense clouds of gas that litter the galactic environment, its immense gravity would have compressed the gas, triggering a firestorm of star formation in its path. It was a gardener planting seeds of light as it fled. The force required to kick a supermassive black hole out of a galaxy is almost unimaginable. The most likely culprit is a gravitational wave kick, the cosmic recoil from the most powerful merger in the universe. Picture the final moments when two supermassive black holes, after a slow, spiraling dance, finally collide and become one. If this merger is not perfectly symmetrical, if the two black holes are of different masses or have misaligned spins, the event can be likened to a rifle firing a bullet. The newborn black hole can be shot out in the opposite direction at speeds of millions of miles per hour, a consequence of the universe's own laws of physics. This observation is more than just a spectacular curiosity. It provides some of the strongest indirect evidence yet for the existence of gravitational waves from supermassive black hole mergers, ripples in space-time predicted by Einstein but not yet directly detected at this colossal scale. It suggests that the centers of galaxies are dynamic, violent places where such cosmic ejections might be more common than we ever suspected. What happens to a galaxy that loses its central black hole, its gravitational anchor? The evolution of that entire system will be profoundly altered. This single fleeing giant forces us to rewrite the story of how galaxies live and die, revealing that even the most massive objects are not immune to being thrown out into the cold, dark void. This immense pull we feel raises a profound question about our motion through the cosmos. While some objects are violently ejected, our entire galaxy, along with countless others, is being drawn toward a specific point in the void, a mysterious gravitational anchor known as the Great Attractor. Located in the direction of the constellation Centaurus, roughly 150 million light-years away, this anomaly represents a staggering concentration of mass, a gravitational sink pulling us and our local galactic neighborhood inward at a breathtaking speed of over 2 million kilometers per hour. The most frustrating part of this mystery is that it lies hidden behind the crowded plain of our own Milky Way, in a region astronomers call the Zone of Avoidance. This is not a forbidden zone, but a celestial blind spot where the gas, dust, and countless stars of our galaxy's central bulge obscure our view of the universe beyond. It is like trying to see a distant mountain range through a dense, perpetual fog. For decades, the true nature of the Great Attractor was a complete enigma, its immense gravitational pull the only clue to its existence. How do you map something you cannot see? The answer has come from looking with different eyes. Infrared telescopes, like those aboard the Hubble Space Telescope and the Wide Field Infrared Survey Explorer, can peer through much of the obscuring dust, seeing the heat glow of galaxies hidden behind the cosmic murk. Radio telescopes have been even more crucial, mapping the distribution of hydrogen gas in galaxies we cannot see with optical light. This multi-wavelength detective work has slowly revealed that the Great Attractor is not a single, unimaginable object, but likely the heart of a colossal supercluster of galaxies, a dense knot in the cosmic web known as the Laniakea supercluster. Laniakea, a Hawaiian word meaning immense heaven, is our home on the grandest scale, a vast filament of over 100,000 galaxies all flowing toward the same gravitational center. The Great Attractor is the central gravitational valley of this supercluster, the point toward which everything within its domain is slowly, inevitably draining. Yet the story does not end there. Our entire local universe, including the Great Attractor itself, is being pulled towards something even larger and more distant, a monstrous concentration of mass known as the Shapley Attractor. This reveals a cosmic hierarchy of pulls and tides, a river of galaxies within an even greater river. The Great Attractor is not the ultimate destination, but a major waypoint in our universe's grand and silent flow. The same violent gravity that ejects black holes also orchestrates the most spectacular mergers in the cosmos. Galactic cannibalism is a slow, relentless feast where larger galaxies consume smaller ones, but sometimes two giants of equal size collide in a dance of mutual destruction. A perfect example of this is the pair known as the Mice galaxies, located about 300 million light-years away. These two spiral galaxies, forever locked in each other's gravitational embrace, are in the midst of a billion-year-long collision. You can see the violence of their interaction written across the sky in the form of two immense, sweeping tails of stars and gas, each stretching far out into the intergalactic void. These are tidal tails, cosmic debris pulled out by the immense and competing gravitational forces, as if the very substance of each galaxy is being drawn out into long, brilliant streamers. This is not a gentle process. It is a gravitational maelstrom that churns the galaxy's internal structures into chaos. Vast clouds of hydrogen gas, once placidly orbiting the galactic cores, are now slammed together with incredible force. This sudden compression is the ultimate trigger for star birth. Within those colliding gas clouds, density soars and pockets of gas collapse under their own gravity, igniting into millions of new stars all at once. These starburst regions glow with an intense blue light, a telltale sign of hot, young, massive stars. The entire system becomes a stellar nursery on a catastrophic scale, a firestorm of creation born from utter destruction. The final outcome of this cosmic ballet is a complete transformation. The elegant, ordered spiral arms of the two galaxies will be entirely erased, their structures scrambled beyond recognition. Over hundreds of millions of years, the long tidal tails will either fall back into the main body or be lost to intergalactic space, and the two distinct cores will slowly merge into one. What will remain is a single, much larger and featureless galaxy, a giant elliptical galaxy. This new entity will be mostly devoid of the cold gas needed to form new stars, its period of frantic birth having consumed its future fuel. The cannibal galaxy is a testament to the universe's dynamic life cycle, a cycle where beautiful spirals are the youthful phase and colossal ellipticals are the aging giants, built from the remains of countless violent mergers. Every giant galaxy we see, including our own Milky Way, carries the scars of such ancient feasts in its history, a reminder that the cosmos is in a constant state of beautiful, violent renewal. Just when we thought we had mapped the grandest structures, the cosmos began to whisper with a new, frantic energy. These are the fast radio bursts, or FRBs, millisecond-long flashes of radio waves so powerful they can outshine entire galaxies for the briefest of moments. The first was discovered in 2007, buried in archival data from a radio telescope in Australia. A single spike of energy so intense and so brief that astronomers initially dismissed it as terrestrial interference, a glitch from a passing satellite or a microwave oven on the observatory grounds. But then they found more. Each burst is a cosmic scream, a tremendous release of energy that travels across millions, even billions, of light years to reach our telescopes. For years, their greatest mystery was their origin. Pinpointing the source of an event that lasts less than the blink of an eye is a monumental challenge, like trying to find the location of a camera flash in a dark, crowded stadium using only a single photograph. The breakthrough came when astronomers began detecting repeaters, FRBs, that flashed from the same patch of sky not just once, but over and over again. This ruled out one-time cataclysms, the kind of event that destroys its source, like a star exploding or two neutron stars colliding. The repeaters pointed to an object that could survive these immense outbursts, something that could power multiple bursts. The prime suspect now is a magnetar, the highly magnetic, rapidly spinning corpse of a massive star. Imagine a neutron star, an object so dense a teaspoon of it would weigh 1 billion tons, but with a magnetic field 1,000 trillion times stronger than Earth. The stresses on such an object are unimaginable, capable of causing starquakes that crack its rigid crust, releasing pent-up magnetic energy in a flash that we see as an FRB. It is a cosmic transformer, turning immense magnetic power into a focused radio scream. Yet some bursts are so enormously energetic that even magnetars strain to explain them, leading to more exotic theories involving merging black holes or the violent evaporation of primordial black holes from the dawn of time. Each new detection, especially from these repeating sources, provides another crucial clue, allowing scientists to use the bursts as probes. As the radio waves travel through the sparse gas between galaxies, they are stretched and delayed in ways that reveal the amount of material they have passed through. These flickers are not just mysterious signals, they are illuminating the invisible cosmic web itself, using the most fleeting of flashes to map the vast, empty spaces between the stars. The fleeting flashes of fast radio bursts reveal a universe in constant motion, but a deeper challenge lies in the very foundations of cosmic history. A new generation of eyes has turned toward the dawn of time, and it is seeing things that should not be there. The James Webb Space Telescope, with its unparalleled infrared vision, has peered back to a period just a few 100 million years after the Big Bang, a time when the universe was a mere infant. There, in the primordial dark, it found galaxies that in itself was expected. What was not was their shocking size and maturity. These infant galaxies are colossal, filled with vast numbers of stars, and their structures are already well defined. They are not the faint, chaotic blobs of early star formation that many models predicted. They are fully fledged, massive cities of stars, existing at a point in cosmic history when they should have barely begun to form. This discovery strikes at the heart of our understanding of how the universe built its first large structures. Our prevailing model relies heavily on the guiding hand of dark matter. After the Big Bang, slight density fluctuations in the dark matter are thought to have created a cosmic scaffolding, a web of invisible halos that slowly pulled in normal gas, providing the gravitational seeds for the first stars and galaxies. This process was believed to be a slow, gradual buildup over billions of years. The existence of these impossibly early, massive galaxies suggests this timeline is catastrophically wrong. It implies that the dark matter halos must have formed far more quickly and efficiently than anyone thought possible, or that the conversion of gas into stars was astonishingly, violently productive in the early universe. Some galaxies even appear to be too massive to exist within the standard model's constraints for that era. Astronomers are now being forced to question the fundamental rules. Did the first stars form in a completely different way, perhaps in gigantic, monolithic collapses of gas that bypassed the slow, steady growth we observe later? Could the properties of dark matter itself be different from what we have assumed, allowing structures to clump together faster in the ancient cosmos? The James Webb Telescope is not just showing us the baby pictures of the universe, it is handing us a photograph of a toddler that is already 6 feet tall. This forces a profound and thrilling reevaluation of cosmic evolution, suggesting that the first chapters of our universe's story were written in a far more dramatic and explosive script than we ever dreamed. The James Webb's findings shake the very foundations of cosmic history, yet another discovery challenges our understanding of the universe's final boundaries. Across the observable cosmos, entire clusters of galaxies are streaming in a single, coherent direction, a motion so vast and unexplained it has been named the dark flow. This is not the expansion of the universe where all galaxies recede from each other. This is a directional current, as if some immense, unseen force is pulling these colossal structures on a course toward a specific point beyond our vision. The source of this motion remains a complete mystery. When astronomers map all the known matter and energy in the observable universe, including the gravitational pull of the Great Attractor and the even more distant Shapley supercluster, the combined force is not enough to account for this flow. The motion persists, suggesting a gravitational tug coming from something so far away its light has not had time to reach us in the entire history of the cosmos. This leads to a staggering possibility. The dark flow could be evidence of a gravitational influence from a region of space that lies beyond our cosmic horizon, a part of the universe that is forever outside our observable bubble. Some cosmologists take this idea even further, proposing the most radical explanation of all. Perhaps this flow is the first tangible evidence for the multiverse. In this theory, our universe is just one bubble in a vast cosmic foam of other universes, each with its own physical laws. The dark flow we detect could be the gravitational pull from one of these neighboring universes, a ghostly hand from another reality gently tugging at our own. This concept pushes cosmology to its absolute limits, forcing us to consider that the map of everything we know is just a small island in an infinite, unknowable ocean. If true, it means the grand structures we study are not merely drifting in emptiness, but are caught in a current flowing from a shore we can never see. One star's dramatic performance sent a ripple of excitement through the astronomical community. The red supergiant Betelgeuse, a familiar shoulder in the constellation Orion, began to falter. In late 2019, this brilliant beacon, one of the brightest stars in our sky, started to dim. Its light faded so dramatically that by early 2020, it had lost nearly 2/3 of its normal brilliance. For a star known to be nearing the end of its life, this was a potential final act. The speculation was electric. Was this the long-anticipated prelude to a supernova, a stellar death that would outshine the full moon in our daytime sky? The possibility that we might witness such a cataclysm in our cosmic backyard was both thrilling and humbling, but Betelgeuse was not ready for its final blow. As astronomers trained a battery of telescopes on the star, a more nuanced story emerged. The great dimming was not caused by an internal collapse. Instead, it was a cosmic veil. The star had ejected a colossal cloud of its own material, a plume of superheated gas that traveled away from the surface and then cooled into an immense cloud of fine dust. This dust cloud, drifting between us and the star, acted like a temporary shade, blocking a significant portion of Betelgeuse's light from our view. This event was not a death rattle, but a cough. It provided a stunningly clear look at the messy, dynamic process of a supergiant's final years. Stars like Betelgeuse are cosmic factories, fusing heavier and heavier elements in their cores. As they run out of fuel, they become unstable, pulsating and heaving vast quantities of their outer layers into space. The Great Dimming was a live demonstration of this process, a single, spectacular burp in the long, slow death of a giant. It showed us that the path to a supernova is not a quiet, steady fade, but a series of violent, dusty eruptions. The star has since brightened again, returning to its familiar rhythm, but it left us with a profound lesson. We learned that we can watch these final stages unfold in real time, decoding the subtle signs that herald one of the universe's most spectacular finales. Betelgeuse will explode one day, and when it does, we will be watching, armed with the knowledge gained from its great, mysterious dimming. That single, silent particle traveled for 4 billion years to reach us. In September 2017, a tiny, almost massless particle known as a neutrino slammed into the pristine ice deep beneath the South Pole. It was detected by the Ice Cube Observatory, a colossal instrument made of a cubic kilometer of Antarctic ice, strung with thousands of sensitive light detectors. This was not just any neutrino. It carried an energy over 100 times greater than the protons circulating in the Large Hadron Collider, a sign it was forged in one of the most violent environments in the universe. For the first time, astronomers could trace its path backwards with incredible precision, and it pointed like a cosmic arrow to a distant blazar, a galaxy 4 billion light-years away. At its heart, a supermassive black hole was feasting, and from its poles, it was firing jets of radiation and particles moving at nearly the speed of light. By sheer, staggering luck, one of those jets was aimed directly at Earth. This single detection marked a revolution, the dawn of multi-messenger astronomy. For centuries, we have studied the cosmos by observing light, from radio waves to gamma rays. But light can be obscured, scattered, or absorbed by dust and gas. Neutrinos are ghostly, neutral particles that barely interact with anything, flying straight through planets and stars as if they were not even there. They are cosmic messengers that travel directly from their source, carrying information from deep within the most powerful engines in the universe. By combining the neutrino data from Ice Cube with observations from gamma-ray telescopes, radio telescopes, and optical observatories, scientists could pinpoint the blazar as the source with absolute certainty. It was like hearing a sound and instantly knowing where it came from, what made it, and how powerful it was. This event proved that these distant, jet-spewing black holes are natural particle accelerators of almost unimaginable power, capable of hurling fundamental pieces of matter across the universe. We are no longer just watching the cosmos. We are now feeling its vibrations and listening to its whispers, opening a new window into the most energetic and hidden processes shaping our reality. Yet this planet from the future is not the only world that defies logic. A star named Kepler-78, slightly smaller and younger than our own sun, holds a secret in a dangerously tight embrace. Circling it is a world known as Kepler-78b, a planet that by all rights should not be there at all. It is almost a perfect twin to Earth in both size and density, a rocky world that could feel hauntingly familiar. But its orbit is a cosmic prison sentence. This Earth-like planet completes a full orbit around its star in just 8.5 hours. A year on Kepler-78b passes in less than a single Earth day. Its proximity to its host star is so intimate that the surface is a raging inferno, heated to temperatures well over 2,000 degrees Celsius, hot enough to melt rock and strip the very ground into a perpetual lava ocean. The existence of this world poses a profound and direct challenge to our theories of how planets are born. We believe planets form within a protoplanetary disk, a vast, spinning platter of gas and dust that surrounds a newborn star. Close to the star, the disk is ferociously hot. So hot, in fact, that the region where Kepler-78b now orbits would have been a furnace where solid dust grains and rocks could not possibly condense and stick together. The building blocks of planets would have remained vaporized, unable to form the pebbles that would eventually become worlds. So how did this planet get there? It could not have formed in its current location. Astronomers are left with two unsettling possibilities. The first is that it formed much farther out, in the cooler regions of the system where rocky planets are supposed to assemble, and then somehow migrated inward. But the physics of such a migration are incredibly messy, and it is difficult to explain how the planet avoided spiraling directly into the star. The second, more radical idea is that it is the surviving metallic core of a much larger gas giant, a planet like Jupiter whose outer layers of gas were completely scorched away by the intense stellar radiation, leaving only its dense, rocky heart behind. Kepler-78b is a paradox, a world with the composition of a home but the environment of hell, forcing us to question if we truly understand the opening chapters in the life story of any planet. From the silent echo of the wow signal to the violent belch of a feeding black hole, each of these 25 cosmic events is a testament to a universe that thrives on the bizarre. We have wandered through gardens of diamond planets and witnessed stars that refuse to die, felt the invisible wind of a dark matter hurricane, and charted the course of runaway black holes. These are not mere anomalies, they are the vital signs of a cosmos that is endlessly creative, chaotic, and alive with mystery. Every one of these profound puzzles, from the impossible galaxies seen by the James Webb Telescope to the inexplicable dark flow of entire galactic clusters, serves as a powerful engine for human curiosity. They force us to question our most fundamental assumptions, to tear up old textbooks and write new ones. They remind us that the universe is not obligated to make sense to us, and that its greatest wonders are often hidden in the details that defy all logic. So, as we look up at the night sky, we are not just seeing points of light, we are looking at a canvas of infinite possibility. Which of these cosmic mysteries captured your imagination the most? Was it the ghostly whispers of fast radio bursts or the haunting geometry of the red rectangle? Share your favorite in the comments below, and if you are ready for more journeys into the unknown, be sure to subscribe. Our next adventure into the strange and wonderful is already waiting.